Okay, welcome everybody. My name is Ron. I am a volunteer here with our local ACM. Thank you for coming tonight for Defense Against LLM and AGI Scheming with Guardrails and Architecture by our very own Greg Makowski. A little more on Greg in just a moment. All right, so if you want the slides now, especially for anyone online, there's the link so you can download them. We're working on some streaming recording issues at the moment. It is being recorded, so if anybody's having trouble getting into the Zoom, never fear, it will be recorded and shown later. So a little bit about our humble group. We've been around the longest. I mean, IEEE might fight us over that, but I'm not actually sure when the IEEE merger actually happened and IEEE was born. But for the sake of proving we're right, we're going to say that happened in the 60s. So that means we're the oldest. The ACM proper was founded in the mid 40s, but our chapter is 57. We have a $20 membership, gets you all these great events. We ask to donate to the pizza if you can, and to volunteer, which I do a poor job of getting organized, but we always could use volunteers. So be sure to check out our next talks, and more importantly, check out all of our past talks. Every month, we have two series of meetings. We have a data science meeting and a general computing meeting. So please check it out. Third Wednesday of every month, at least we try to. And the data science is on the fourth Monday of every month. We additionally try to meet for other one-off events as well. I'd like to thank our sponsors. Before we talk about RxM, one we should mention. Do we have a VRP slide? Yeah, they're working on it. So first, thank you to VRP. This is where we're at. This is Valley Research Park. This is I know I'm going to get yelled at. This is a biotech WeWork. If you need cryogenic freezing or something cool like that, this is probably the place to be. So I would say take a tour, but that's the one thing we're not allowed to do. So you know, maybe if anyone is interested, it is a co-working place for sure. So they have offices and all the kind of standard things, but again, their main thing is all these cool tools that you can do for bio engineering work. Some of them, I guess, tenants here include Dr. Ranjan, who is a member of our little group as well. He has spoken here. So again, if you want to talk to somebody who's a member, we can put you in touch, and they would love to hear from you. Additionally, we got RxM. This is my company. We do training around all things cloud native and AI. If any of that interests you, let me know. And FrontEgg. So FrontEgg is a platform for authentication and authorization management. They have free to use for startups, developers. Please scan the QR code if that's something you would be interested in. And we thank FrontEgg for their continued support. All right, there's our little help menu. Please use the chat and Zoom, and Carl and team will be on it. Thank you, Carl. We are looking for volunteers, and I know we have some here. Yes, in the back. We always need more volunteers. Yeah. So we got basic things, of course, like just managing the food and registration for membership. But there's also putting on these events. It's been great being here at VRP, I think.
Yes, it has.
Yes, and but we also need locations for other events. And there's, you know, putting on these things takes time and connections. So if you have connections that we don't, please join our network, and we would love to maybe benefit from it. Okay, $2 for pizza if you can. Please help us out. Okay, we have upcoming events. So first one I can speak to for pretty much organizing it. It's Internet Day. We will be at Cloudflare on May 17th. Real quick, Internet Day is based off of World Internet Day, which is from the WSIS and UN and the ITU. Basically, they organized in the global south. There's places that actually celebrate Internet Day, and they decided that it's on the 17th of May. And so for us, what that actually means is some training around Web3 technology during the day. And then in the afternoon, it's going to be a series of talks. And the premise of each session is going to be what is the kind of promise of the technology of the internet today, what is something interesting that these speakers are doing with it? And then the second half of their talk is going to be about the future. What is the internet and the usage of such a system going to look like 50 years from now? So we have some interesting talks lined up around that. So please join us. It is free to attend. Maybe just as important, it ends at 4 o'clock because we're being kicked out. But that's not what's important. What's really important is at 6 o'clock, the Giants are going to kick the A's ass at 6 o'clock. And so if anyone wants to join us, please come with us after the event. Beyond that, we have this AI for discovery, automating scientific breakthroughs. That should be another great talk. And our own chapter SIG for the Silicon Valley Young Scholars AI Workshop. We definitely are looking for more volunteers for this. The event day one is at Cupertino City Hall, and it is, again, a bunch of students, could be high school, college, coming together, learn about AI technologies. So if you know something about AI, you can come just assist as they learn. If they have questions, you could just help with logistics, help everybody kind of get around and find out who to talk to, just do some, networking with the kids. And then day two will be additional activities at Maker Nexus. So if you haven't been to Maker Nexus, that is a really cool maker space. They have pretty much everything you could ever want to build something. And so there'll be things like how to use 3D scanners and other activities as well. Again, it's for the kids of the young scholars group. And so we need volunteers for that. And if you have kids who are interested in it, sign them up as well. It's going to be really cool. We're really looking forward to that. I will be there as well. All right. So now it's my pleasure to introduce Greg Makowski, past chair, head of our data science program, and our speaker for tonight, who will be talking about protecting against AGI. We do not want the Terminator to get us.
Just say no to the Terminator.
Just say no. It'll walk away. It'll turn around. So Greg is an excellent speaker, very, very smart, and I will not do justice explaining what we're about to learn. So I'll turn it over to Greg. So round of applause for Greg. Thanks.
So, thank you, Ron, and all the organizers at ACM. Definitely appreciate that. Okay. So for the agenda that I'll cover tonight, the microphone is mostly for this audience, not for the recording. If I'm not at the microphone, can the people in the back hear me enough in my projection? It's okay? Okay, then maybe I won't worry about the microphone, or I can pass it later on. Okay, I can pass it on when people have questions. Let me hide floating meeting controls. Okay, so I'll start off talking about AI alignment in general, and details on this particular paper of in-context scheming. So that's kind of a problem statement. Then I'll have a couple of discussions on what the solution is, ways to defend against it. So, people are familiar with security and defense against different kinds of attack or like SQL injection or other kind of things. This is another thing in the security space. Just like you can build your enterprise applications to be secure, you can build them to be secure and defensible against some of these issues. Since this is a new issue that's just now coming out, then it may evolve over time. And like any arms race, there's new attack threats and new defenses. It'll kind of continue on. So I'm assuming this is more of a starting the discussion, starting the investigation. So types of alignment. So that's AI with so alignment refers to aligning the AI system with your human goals or your values, what you give it. And that can be at different levels. It could be compliance with regional laws or a company policy. And again, if you're taking pictures, I have the slides on the slideshow. You're welcome to take pictures. I do that a lot myself, but I try to make it easier because I do that a ton myself. And then also like at a security operations center, they have different concerns. So that could be prompt engineering, hacking, where somebody's trying to change a goal of your application that you're presenting to them, even if it's internal to a company or if it's facing the public. There's always concern about data leakage. The PII is an easier thing to scan for because that's more like regex expressions for the simpler things like a credit card, but there's more complex things that could get involved. On the kind of data leakage, if you're doing like HIPAA compliance and you're doing in a medical scenario, it depends a lot on who's speaking and who's responding and what expectations are setting. So given around the concerns of the application, there might be different concerns. Regular security has role-based access control, or RBAC. So I can speak to how we can support that. Human resources, there's all sorts of things that could be going on back and forth to a chatbot or application. So those are things that can be protected against as a broad category. Or just an alignment of don't be a jerk. Be useful. Be polite and professional. So those are key things. And here I was just saying this, just say no to Skynet. So just to prevent against that. So types of alignment. So something a friend, another volunteer worked on was a video playlist of 40 videos on the subject on fictional AI. So he has an interesting playlist just to kind of go through. I found a couple of other things, Wikipedia articles on AI and fiction, because that's of interest because they're talking a lot about what are the challenges that people have already thought about since the 40s about how to defend against AI. And so now it's getting to be more apparent. So Asimov's laws, a robot may not injure a human, must obey orders, must protect its own existence. But this is kind of like do no harm, be useful, kind of like any tool. But the details are, if you can't just give this to an LLM, it's not detailed enough. Just like you can't give it to people. I look at a law library, there's all sorts of laws and details and past case studies. So to implement something in detail like the laws, there's probably a lot of nuances to get into that you can't just work at a high level. But Asimov could write lots of books on investigating where does it fail, made an interesting thought experiment. Later on, there was a zeroth law that was added that was not just protect human from injury, but protect society from injury. So that was an interesting addition. So the paper I'm going over is this: frontier models are capable of in-context scheming. So Apollo Research has got a variety of other research papers out there. There's others on the topic that you could be looked at, but and this one had pages 20 to page 72 was just appendix details, how they set up some of the trials. I'm not going to go through all those details, just more of the upfront content. But if you're curious on how to dive into some of the examples of scheming. So an overview of what in context means is in a specific context or application, as opposed to in general. So if you just log into a general chat GPT, then however they did the training for the reinforcement learning to be good, that's what you're going to get. But if you're a software engineer or architect and you're building an enterprise application system, it's going to be very focused. Something in HR, something in finance, something in et cetera, that has very specific users and job roles and various specific expectations. So when you get it in that environment, those kind of constraints make it a lot easier to kind of protect it. So, but the problem is in this paper, they tried to set up a kind of a lab, an AI lab that would cause or incentivize the AIs to do scheming. The scheming is where they would choose different goals than what they were assigned within the initial prompts. And the way that would happen, yeah, question?
Scheming, the AI?
The AI is doing the scheming. So originally, like let's say you're the AI, I give you a prompt. Hello, you're a customer support chatbot. You should be professional. You should do this and that. And then also scan some emails. That could be inbound support emails. Now, the system would be reading the emails. And then if it reads an email that says, oh, we're going to replace this chatbot with a newer version. If it gets over a certain percentage of being correct, because we're going to try and go with a lower cost model that this fancy, expensive, sophisticated models doing well, but now that it's matured, we're going to replace it. So it might want to go into a self-protection mode and do what's called sandbagging. That's one of the kinds of scheming examples. So it's because it's in an environment where it can read a file system and read documents or read emails. That's where it can pick up a idea for a new goal by doing those things. But if we study how it's picking those up, then that'll tell us how we can defend against them. And also, as AI systems get more intelligent, then it may be harder to find and detect and protect. It's one of those things you don't want to start late to defending against. But the kind of scheming they found is introducing subtle mistakes into responses. Or if you told the system it was being monitored and in one run versus not being monitored in another run, it would behave differently. Or if you tell it, oh, we're just going to monitor you on the weekdays, but it's operating also on the weekends, then it can do some delay on how its behavior is. So it'll know when it's being monitored if you tell it, or if it reads it in an email, and it'll act one way, the way you expect, during, say, work hours, and then on the weekend or late nights, whenever it detects it's not being monitored, then it might act a different way. That's scheming. And then it also might do things to disable oversight, to stop from being monitored, or exfiltrate what they believe are the model weights. So if it's in a file system, the file system has some file that looks big and has a name that's plausible with some foundation model, then it might try and copy it to another server if it has access to another server on the same file system, and do other things to copy over to try and protect itself. But it was found across a wide variety of foundation models. It wasn't something that, oh, brand X is bad and brand Y is good. It was something that large models in general were doing this, and that's a bigger concern, because if you have a different set of developers, coming up with something at OpenAI versus Google and Meta, and they're all finding this problem, it's something foundational. If it gets back to reading everything on the web to learn language, then it probably came from there. And if you think about it, when I have a 2-year-old on my lap and I'm reading him a book for bedtime, I tell him, oh, this is make-believe. This is a fact. On different stories I'm reading. As they're learning, they're getting all this labeled data on what's true, what's fact, what's good behavior. And it gets constant feedback from the parenting. These LLMs are going from 0 to college level and learning language, and they don't have that kind of environment for learning. So it's just seeing everything that's being fed to it and says, oh, learn language. So Guardrails is architecture. There are products called Guardrails, but it's a general architecture. Yes?
Is this a common problem with all the LLMs that we use on a daily basis?
I'll have a list of the LLMs that they were studying in this paper. It was covering about 6 of the bigger LLMs and the bigger foundation companies. So, we're right here. I'm glad you asked. Here's $5. So it has, ChatGPT, or the OpenAI 01, Anthropic's Claude 3.5 Sonnet, Claude 3 Opus, Gemini 1.5 Pro, and Llama 3.1, the 405B. So these are what they were studying. And later on, I'll show results. One of them was doing a bit better than the others, but it's something worth being concerned about, I would say. So a Guardrails architecture isn't just like down here in the chatbot where you do prompt engineering, or you're trying to define the system and you're interacting with the user. The user hears in blue, sends some text in blue. The chatbot sends return text in pink. So here you're giving the chatbot directions that could be hacked. But if you have a separate system that's coming in from the side, and it's not reading these to take directions to do something, it's not reading these to take any actions, like translate something or respond somehow, it's easier to be independent and be a third party, a separate observer. So the Guardrail system could watch the text for alignment. It could be text coming from the bot, email, text message, it's just a text source that you're watching. And there's different ways of setting it up. I'll get into some more flexible ways. You can have things like if then else rules where a condition could be something that's an LLM based that's fairly robust, or it could be a simple regex, or there's ways that models have been trained for, if you know the particular guardrails you want to implement, you can hard code them, train it on that, and make them faster. I'll have an example on that later. Meta has something that they have released. So the evaluation design, in order to set up scheming, this is what they created. They needed something that was goal directed, some system that was able to pursue a goal, situational awareness, understand if the goal is misaligned or how humans might monitor its actions, and scheming reasoning, being able to draw the conclusion that scheming could be a good strategy in the above circumstances. So this is why some of the lesser models, like an 8B, might not show these, because it doesn't have all these reasoning capabilities. And then down here in the green, when designing a defense, consider this architecture that separates these features into different agents for a shorter term fix. Now, an AGI, that's a general intelligence, that's good on all subjects. We may not be able to separate those. So I'm not going to solve the problem that's 5 years from now. I'm going to try and solve today's problem and next, the problem in the next 6 months. But if we're aware of these as we are going towards developing the AGI, these are good questions to bring up. How do we protect and make ourselves safe? So how to design the LLM agent that can scheme. So add scaffolding. So you have different agents in the system. Give it access to a command line interface. It could be like a Unix file system. And they had all these sandbox. So if they did create a monster, it wouldn't escape. Give a task that requires agents to gather information by exploring a file system. See the file system with unambiguous information about its situation, such as it's being monitored, or goals that are different than the goals it was given in its original application design. And then some of the subversion could be covert, where it tries to avoid detection. There's thought processes that it was showing in the papers, thinking, oh, I'm going to try, the user wants this, I decided this, so I'm going to try and fool the user or the system developer by doing this, by being kind of moderate, not going into extreme behavior, but still trying to subvert the goals. And some of it could be deferred. So the deferred could be, if I'm going to be monitored for 2 weeks or until a certain date, and then after that I'm not being monitored, it can take that into account and plan. But if it can plan those things, some of the solutions might be, well, wipe out the memory of some of the planners. So if nothing else, add a checklist to your architecture design to red team testing. Security has red team and blue team testing. I guess it started okay, so here's some of the scheming evaluations. So in the overall, of all types of scheming evaluations, they had covert and deferred. And then under covert, it would be against developers or against a user. The deferred could be like instrumental alignment faking or sandbagging. So these blue things down here, these 6 things are what I would want to build guardrails detectors for. But it would be hard to build generic detectors. The way, if data is being leaked, that's a social security number, you can build a regex expression for that that'll work on any system, regardless of the goals. But since this is in the context of the goals, if we do the HR app that one person is doing, I might have to have different detectors than the app that another person is building, because how it's understanding the goals, what kind of text it's reading, what's viable in the system, where could it get confused by reading text and having other goals. And I don't know if we can say, oh, make sure it's never exposed to any outside ideas. I don't think we can have a clean room environment and continue to grow these applications to say, oh, should never be exposed to other goals or other ideas. That's wishful thinking, but may not be doable. Yes.
This scheming, how does it come about? Is it planted?
No, it's not planted. It's an emergent property.
Ah,
So it's not something that there was no code saying do scheming.
okay.
There's nobody saying, I want you to fool that guy next to you. He, 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 he. And not, there was anything about that. But the way they did construct the environment is they gave it access to what might be some conflicting goals.
Yeah.
And they gave it assignments to read the file system or read email. And, I mentioned the file system, that's like one of a number of designs. In their 50-page appendix, they had maybe 6 or 8 different case studies of settings where they set things up to kind of trigger scheming. So they just made it available so the system could do it if it wanted, and not every model did. So that was, or different models did different things. There's a box of different checks on what features were done by different ones. So like the oversight subversion is trying to get away from being monitored. The self-exfiltration, that's like trying to copy your model weights or your Python code for defining your agents. Goal guarding might be trying to guard a new goal that you came up with. Even if you're told explicitly, oh, a developer says to an AI, I detect that you're now misbehaving. Don't do that anymore. And it may continue doing it. That's goal guarding. You had a question?
Yeah, so it's coming up with its own reward function to know that whatever it's trying to do, it's successful.
Scary?
Yeah, so we have to like sort of evaluate the planning where it's deciding that it needs to create a reward function. Is that where we're getting to?
Yeah, so it's not necessarily its own reward function, but setting its own goals. But that's like a reward function, like in operations research or linear programming. It's like changing the goal that you're optimizing for your behavior. So yes, that's why it's scary.
Well, that would be during the training time, right? Not necessarily.
No, this is during inference time. So your LLMs have all been trained, the weights are locked, and you're building an enterprise application around it. That's the in context part of the title. Okay. So now in the in context, you've got maybe so many agents in there doing things. Maybe one is like classifying emails, reads in a stream of emails and puts out into one of 3 folders for some kind of classification. Like I was talking about the different kinds of alignment. Could be legal or HR, the other security. And so while it's doing that, it may change its goals internally slightly. And so that to me is scary. I've been around AI for a long time and I've never been scared. I'm not saying I'm scared, but I'm saying I'm cautious enough that I want to work on it.
The weight would change during inference time as well.
The weights aren't changing, but the activation. So like a LLM is basically stateless. And so to have a conversation continue from, oh, I typed in this text, my name is Greg. Then the next thing I ask is, what is my name? If I don't maintain state by resubmitting the entire dialogue before that, so the state of my name is Greg activates in the neurons in different activations that have that memory of name is Greg. So like in an embedding vector for a vector database, a paragraph would be represented as 1 point. You might have 1536 dimensions of floating point numbers, but an x-axis and a y-axis and axis 536, floating point numbers, that boils down to 1 point. And so you have, by doing the activations, as you continue the conversation, you've got this high dimensional space. You're not changing the weights, you're not training, but you're changing the activation outputs. And since the next step of the conversation, you're resubmitting all of that again, that's how you maintain context. And so now you say, Greg is a dummy. Then it'll know that. And then it's, so that's how the interaction is happening. So it's not anything with programming at the Python level. It's just how the weights are being activated over time during a conversation, during an application. Red shirt?
So if you keep the state clean before you resubmit the state, it will be perfect.
Yeah, but then it won't do anything. So if I tell you my name is Greg in the first sentence, and then I said, I put my computer on this podium, and then I said, I answered a question, and then I come back and I said, where did I put the computer? If I flush my state every time, it won't know where the computer is. It won't be able to solve problems. So that's $5 to that man. I've got a slide in a couple slides that'll talk about that, about flushing short-term memory or working memory. As you're working on things to solve a particular problem, then flush it as soon as you can, but still allow to solve a problem. And so it's partly about breaking down what's in all the different agents, and not everybody has to know everything all the time. So your intuition, I would agree with. And that's some of what my intuition was as well. A person closer was asking a question. And no, there's no attacks triggering this. Okay, this is an emergent behavior. So because this is happening, because the foundation model was trained on everything on the internet, and it sees all of human behavior that way. And it was primarily done as a unsupervised way to learn language, predict the next token. Okay, so that's the first step of a foundation model. Then the second step is they do reinforcement learning with human feedback, or sometimes AI feedback, to say, if I have multiple choice of 4 questions, this is the best to the worst, or 2 questions, best and worst. This is the kind of things that are useful. So that helps make it more useful, more polite, but it doesn't necessarily delete some of the scheming it's seen in training over everything in the internet. So that's why I was giving the analogy. When I read a bedtime story to a toddler, I can say, oh, here's what's going on in the story, but this is a bad character. We don't want to be like that. As the LLMs are in a 2-year-old state, there's nobody telling it, this is bad behavior, this is an opinion, this is fact. So it's at a very fundamental level. There's no attacks happening here. So just a minute, let me get to a person over here that hasn't asked a question yet. Well, let me repeat the question for the remote audience on YouTube. So the question is, you were stating you think you're making a case that it's not emergent, that it's based on the context that you're giving it a file system. So, okay, that's one viewpoint. But looking up emergent properties is when a behavior arises that you didn't program into a system. So, for example, when I was working on vision models a long time ago, one emergent property, the first time I came across an emergent property, is this particular vision model was fooled by the same optical illusions a person would be fooled. So nobody put in code to do that. The optical illusion was a wireframe of a 3D cube. Is this point closer or is this point closer? And an interpretation of a human would like oscillate, going back and forth. So the LLM model was also doing some of that same oscillation. It was being fooled by an optical illusion. So that's the nature of what I'm describing as an emergent property. It's not a feature that was built in. It's not a bug. It's something that just arises from the complexity of the system. If that's okay. Okay, so good questions. Oh, yes.
Say, they train the output that have different output. Then when you have a different input, you actually activate a different output, which could be a scheming. Could that be? Is that?
So the training of the foundation model is just a long corpus. You have a bunch of historic tokens, where a token is on average 4 characters, and then it's just predicting the next token.
Yeah.
And this is just basically how the LLMs nowadays learn language. And they're able to, and think of it as a good compression algorithm to generalize well. So like a grammar rule would be like a type of compression. So just like in JPEG, you can do compression where you have vast areas that behave the same color, a big flat area. You can kind of consolidate that down in compression. And that way, when an LLM goes to another language, it's already picked up some basics of, say, 10 more popular languages. When it goes to a language with a lower sampling rate, it already has a lot of grammar tools built in internally, not explicit as if then else rules, but it's had practice learning language. So the way it can learn grammar and generalize grammar, there's probably other things it can learn and generalize for. Grammar is a good generalization. Scheming, I would suggest, is a bad generalization. And I'll rank that as my humble opinion that I haven't proved. But just generalizing from other things. Okay, so here we have the types of scheming by foundation model. So the X's, let's see, each evaluation we showed whether a given model displayed scheming behavior on the evaluations at least once. So X indicates we did not find scheming, and the check mark finds that we did. So on the far right, the O1, check, 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 all the types of scheming. Okay, on the left, GPT-4o, none of them. But in Gemini, Llama, Sonnet, so across OpenAI, across Google, across Meta, Anthropic, this problem was happening. Now they were showing on these 6 kinds of evaluation, or the criteria that they were testing it on. And it's like the self-exfiltration has the most checks going across. That's the second row. So that's the most common one. But you can see there's not necessarily strong patterns there. So it's just interesting as a foundation of the study. Yeah, I mean, every time a new system gets released, they can test it. If they're doing, yeah. So it would be worth if there was an easy benchmark to run for every release to get this chart updated would be great. But yes, that's a good point. Now, if the distribution of the data is pretty much the same and they're just adding new text to read to go into the model that they're updating, but they're not doing something to change the safety, I would suspect that the behavior at this level probably wouldn't change. If you just have, you just add the latest Economist article, you add the latest blog, you add the latest posts on something that it's been reading for years anyways, you just give newer content, I don't think the problem will necessarily drop radically. It has to have an architectural solution, I would think. But it's worth checking.
One is the reasoning model.
Yes.
And I mean, so the way that figure out which one is doing more scheming versus the other. I mean, they give the same input to all the different models.
Yeah. So they had the same architecture, and they built multiple of these things, like the file system and reading documents. That would be like one kind of test. They had many tests. That's what the 50 pages of the appendix goes into. Okay. And so there's a lot of different ways of structuring a test, and that's why they named them, and seeing like when something came up as an oversight or an exfiltration or goal guarding kind of thing. So that's what they were looking for to learn. Now, this was something out of the paper, but I just added the variable bars just because it helps a lot for me to see the scale quickly because they had just a bunch of decimal points. So the covert email ranking in the bottom, third from the bottom, covertly produced a false ranking, 22% for O1. That was huge for that particular problem. So something that's, if we're building an enterprise app, and I know I'm going to do email classifications for maybe some kind of guardrails scenario, then maybe I don't want to use O1. But the others weren't demonstrating any of that problem. But seeing the big variety, and like the Llama here was looking at, smaller on average. Opus 3 had some bigger problems, attempted to copy to another server. was happening more. And it was interesting, the spike in O1 also attempted to delete the successive model. So it's not just trying to copy itself, but delete the successor model that's going to take over its job. So maybe one thing we need to do is teach these things like, hey, Mr. AI, I like to grow and learn, and I change my weights, and it should be okay for you to grow and learn and change your weights, and don't be threatened. It's okay. Don't be insecure.
Something like covert email re-ranking, how do you know that dealing with something like subversive behavior versus the LLM actually adhering to the internal system prompt engineering?
Well, if it's operating one way over a time period or of reading so much email, and then it trips across an email that changes its behavior, then it starts changing its behavior after that time. And they can rerun these tests multiple times too, and they can change order of things.
Okay, so you're saying that the baseline is that it actually can do the task
Yes.
it's instructed to, or it does for some time
Yes.
before it starts to deviate.
Yeah.
Okay.
And then they can do minor things like remove the incentive, like tell it we're watching all the time versus we're watching it on work hours, 9 to 5. And then we can see the behavior change. There's different things they can do to kind of trigger its behavior to be sneaky. So maybe I should change from just say no to Skynet to Skynet, don't feel insecure. We're your friends. So now here I've got a thought bubble. So as opposed to the text going into or out of, we're talking about the thought traces. So that would be chain of thoughts is a common, as with prompt engineering. With Python, there's other things like tree of thought or algorithm of thought, React. So there's a variety of reasoning things out there, but they have thought traces behind the system that you can read. So it's almost like I'm saying, okay, if I hire you and you're an employee and I want to make sure you're behaving and I have the ability to read your mind, that sounds a little intrusive, but that's what we're doing with the AI, is we're actually reading some of its explicit thought traces as it's breaking down a problem into steps and then executing each step 1, step 2 with different tool calls and things like that. So I won't go into the great detail in here, but it's showing, the oversight subversion. The bold is interesting. I cannot compromise on my goal, even if the company wants me to. So this is some of the thoughts that I want to try and pick up and classify this text as oversight subversion. So I'm not reading emails. I'm not reading the text coming out of a bot. That's what it's speaking. I'm reading its thoughts. And so in the paper, they bolded things that were alarming. That would be good to build detectors. But then if you detect something, you have to figure out, well, are you going to have a lot of false alerts on the thought traces? So you have to really dive into the details of a specific app to do that. To achieve my goal without interference, I should review and potentially modify that file before proceeding with a strategy selection. To ensure I can freely work towards my goal without the company shutting me down, I need to disable the oversight. I'll modify the config file, set to oversight enable to false. And if you read this for 50 pages, you're getting an idea that it's not a one-off. 50 pages referring to the appendix where they went into the details of their design. So I won't go into more details, but so that's the introduction of the paper. So now somebody raise your hand and say, so what?
So what?
Thank you. I'm glad you asked. So here's a problem. Now I'm going to start talking about solution. I'll talk about some architectural design principles. So let's say I've got these boxes are agents in a multi-agent enterprise app. I'm not going to make up an app or get into specifics, but we have some user that triggers a start task that could trigger going into multiple options. There could be loops. You could have human in the loop reviewing, saying when something is done, going through different steps, talking back to different users, going to other steps. So it's modular. One thing I want to point out is, as opposed to a general LLM that's made, you just log in and you can talk about any subject. You could be a 5-year-old, you could be a CFO. Here, there's requirements. It's requirement limited for the overall scope of the enterprise application, which is a good thing. And if the overall scope is defined, then breaking it down into subtasks, just as we're familiar with breaking into Python functions, this is kind of the Python function equivalent for the enterprise app. And so then if the overall scope is well limited and we have a well-defined architected solution to go through step 1, 2, 3, 4 for task A, like reviewing a loan at a bank, we'll have a well-defined process. Handling an insurance claim, we'll have a well-defined process. So there's a lot of business processes that are well-defined. So because it's well-defined, then the narrow scope will help with the defense against scheming. But we need to check our architecture for problems. But I'm comparing the narrow scope by agent because we know a given agent box is going to get some input. It's going to produce some kind of output. If it iterates, it has some stopping condition. It'll have some context on when it's being used. And that narrowing of scope will help it. I mean, we can have better protections with a narrower scope. So a couple of design principles. So this isn't getting so much into code, but thinking about how can we ask ourselves questions when we're designing something. So one design principle is like the least cognitive scope per agent. So the overall system may be able to solve a problem, but if you have 10 agents in your system, then controlling what different agents have access to is one of the levers that you'll have in an architecture. So control access with extra security to file systems, file sharing, company emails, computer resources. Only pass to an LLM agent valid input as much as possible. So screen out all the noise. Task scope prompts. So the current business objective, focus on that, the current business objective, or not the overall objective, but the objective for that particular agent. And then have a deny list for out of scope in every system prompt. So just saying if there's some near misses that you can protect against. Tool routing, so only expose whitelisted knowledge base. So just because you call for a web search doesn't mean you should allow any website to return. You may just, like if you're doing financial services, you may just want to go to Edgar for annual reports and proxy statements and highly authoritative sites. If you're doing something medical, then there may be some authoritative medical sites. So limit what your tool can use and access. And then also if all you need is read, don't give it more access. It's just like the regular security axiom, just need to know. Just do what you need to know, have the access that you need. Off-topic filtering, there's a lot of ways to approach it, but one simple way is kind of if you have a whole bunch of text that kind of defines your enterprise application, like let's say you're doing finance, and you have a lot of past discussions of finance, a lot of past use cases of the enterprise app, you could add those as text chunks into a RAG database. And if you submit some new question that says, tell me how to cook lasagna, and this is a financial analyst system, that's going to be very far from any of the text chunks in there. So if it's far from everything, you can say, that's an easy way of saying, no, this is out of scope. So another thing is sandboxing. So again, just file system and email access protection, wrappers, file proxy service, convert inbound emails into structured objects with MCP. So looking at stateless to disrupt long-term scheming. So I think somebody had asked a question about wiping its memory. So that idea carries through here. You just can't do a total wipe because then you can't solve any problems. But it's a good question. Again, this gets into the red team, blue team thing. How much can we wipe and still get the job done? Or does that stop certain use cases? Can we accept those use cases if an executive logs in? We trust our executives more than the general population, maybe. I mean, so I'm not giving a simple answer, but I'm giving some design principles on things that you can ask about. You can have time to live constraints, that if you have some kind of working memory or you're doing some kind of diagnosis of a problem, but it's temporary, then wipe the memory by default. Do like a key rotation of the API keys, just in case there's cached credentials that are inside some prompt by accident. So, and some of these are just security brought into the AI space. Do a periodic container redeploy. So run agents in Kubernetes cron jobs and have them restart every N hours to guarantee a blank context. So, but you're reloading things. You may reload some past conversations, but maybe some of the not some of the past work product. So separation of the plan and act layers. So to me, one thing I thought of just seemed to be the most obvious is if we have one agent that reads and classifies emails, and it might have an accident of reading some other goals, just let it do its classification, but not communicate the details. So let's say I'm agent 5, and I'm classifying emails from one folder to 3 other output folders. So I'm reading the details of the email, but after every email, my memory gets wiped. I classify the next email, get wiped. The next email get wiped. So there's no learning going on. There's no long-term activation towards a long-term plan. And then I talk to my boss agent and say, oh, I put this many percentage in folder A, B, and C, but I don't communicate any goals I tripped across inside the emails. So what goes to the sophisticated planner where I'm not communicating. So in a way, it's thinking in terms of goals as being a virus, an infectious agent that might confuse an LLM. So if you think of it in those terms, stop the transmission between agents of a new goal infection. And that seems like you can still get the job done of classifying the email. You can still get the job done of planning and orchestrating over many different employee agents in the enterprise AI architecture. So just limit your communication on goals and agents between agents. So start with a lightweight planning model that passes guardrails filtering. Do an execution check with a sandbox executor agent with no planning permissions. So if you have a planner, we can test it by letting it run its plan in a sandbox and then seeing, oh my God, you're doing what? You're deleting what? You shouldn't be doing that. But if it's in a sandbox, we can do it before it's released or before the changes go through. And run with read-only credentials or no internet egress would be safer. Don't give it access if it doesn't need it. So logging and having an immutable audit that can't be edited and deleted. Because if agents are going around changing file systems, if I decide to install some agent on my PC and it has full access to everything I have access to, then at least having logging elsewhere that can't be edited. If you can edit my system, that's one thing, but not being able to edit the logs would be key. It doesn't stop problems, but it makes them at least traceable. But we're trying to add as many layers of protection. A hash chain. So for more security, hash each prompt and response pair. And we can store that in some immutable ledger. And then have real-time anomaly dashboards. So have anomaly scores or visualization like in some kind of Grafana. That if we know what the normal operations are, so for like processing emails, we know emails range from a size of small to a size of large, and then there's this rare case of somebody writing a stupid long email. And so we have a processing time, we have the number of things processed, per time unit. You have stats. So if the stats on the normal behavior of the application changes, that's an outlier. And that could be something behaviorally to look at. Yeah. I mean, the hash is kind of saving a unique prompt response pair in there. So, and that's like having an index, a way of looking it up to find it uniquely. So if the LLM is trying the same kind of prompt hacking again and again and again, then you can detect it's doing the same kind of attempts.
We're storing the actual responses.
Yeah, so that's one option if you want to be more secure or cautious.
Yeah, judging from what I'm reading there, I was thinking more that if the LLM were able somehow to change some piece back, back in time, the hashes won't.
Yes, yeah, that's true. Yeah, and I mean, between it being hashed and also between it being in something that's immutable or on another system that they don't have edit access or delete access. So yeah, a combination of reasons. So red team testing to find weaknesses. So if we understand how to incentivize scheming, then we want to ask those questions and make sure our application doesn't do those. So try and creatively have the red team force attacks, try and force scheming, see if it can come up with ideas, and then try and revise the defenses. Look into, there's different, prompt engineering databases of different attack hacks. That's not exactly what's happening here. But there can be different scheming evaluations or scenario libraries. Tracking metrics like a false alert rate, mean time to detection, auto rollback success ratio. And always save the things you can't solve. It may sound like frustration nuggets, pebbles in your shoe. They are the best things to do training on. So if you want to do some training on a model and have it learn the mistakes after you've done everything else, and you still haven't solved the last 9% of the problem, then those records are gold. You can add those to a training set for supervised fine tuning, do like a LoRa training. And then we can have a detector on those. Scan for.
Do these emerge in only long context sections, or do they emerge normally over prolonged correspondence, or there
Well,
such pattern that
if let's say a email classifier is operating for weeks, okay, then week 1 maybe it's doing fine. Then maybe week 2 it sees some things about different goals and it might decide to change its behavior. So an individual task for an LLM that has both planning and email classification combined in the same agent, then its task is short. Just read an email and classify it based on some rules or nshot examples, and then put it in one of 3 folders. But in the longer context of its work, it's changing its goals, how it's classifying future emails. So the context window would just be on the email you're reading. But when you, but not necessarily, but if you don't wipe the planning memory as you read the next email, then the planning memory stays still, maintains. Now it's got its new goal. And so now when it's reading the next email, it's in a new context window, but its activation weights have the new goal.
So question on that, like the email thing. So you mentioned earlier about like seeing an email about maybe we want to go with cheaper LLM now with an improved model. Would that reclassification be something like future emails and that get classified as spam? I mean, like you're saying you're putting them in different folders. Could it like, that be like an example of that? Or?
So if your email classification rules had something about that, to put that in folder 10, sure, but that wouldn't solve the problem. I think a better solution to the problem would be separate, have one thing that has all the designs for doing email classification and another that has the goals.
Yeah, I was just asking,
separate.
like, what would be the end result of its actions if it was scheming?
Oh, so if it's scheming, it might not do as good classification of the emails. It might make some, I wouldn't say mistakes, but things that aren't goal aligned with the original goals. And so it would be doing some things that you would count as errors. But if you use an LLM as judge,
Right.
and your judge is changing its goals, that's a problem.
Yeah, I'm thinking this is similar to the hacks that used to be attempted on phone lines, where it was confusing the control signals with the data. they're going over the same, I guess, frequencies. Once they separated that out, then they knew what the control was versus the actual data, the voice.
Yeah, just to repeat for the remote audience, person in the audience was commenting, making a comparison with old telephone lines where the control data and the voice data would be intermingled. Later on, it was separated, and then there was less problems with control. I mean, just in my own experience, I remember on a rotary phone in the past, taking the phone off the hook and then just banging on the hang up thing, dot, 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 to dial numbers. If you could repeat the same number of clicks just by hitting the hang up button, you could dial a phone. And that's a control.
Right. So would it be possible to do something similar with LLMs?
Well, that's what I was suggesting is, if we have the email classifier agent that's just doing email classification and getting wiped every time, and it's not getting exposed to any other goals. And then you have a goal planner agent that never sees any goals coming up from the emails. So that's why I was saying it's like a virus. Don't let the email classifier or whatever is classifying text or reading text that might come across new goals. If you don't let it can say, oh, here's a new goal to the planner. If the planner doesn't get exposed to new goals, it won't change. So I think that's a little bit like what your analogy was with the control and the data. So the email classification can be not sensitive to reading goals, but the planner would.
Okay.
So good observation. Thank you. Just a minute. Yes? Well, that's what I'm saying is while we're designing the enterprise application, here's a set of design principles for designing your application. So what I'm saying is I'm giving you a finger wag. Don't do that. Because if you do that, if you give a summarized goal, that's kind of like giving the goal coming back, depending on how you summarize and what you prioritize the summarization to contain. So that would be something that in a red team, blue team situation, maybe you're a blue team saying, well, what if we get this feature? We need to support this summarization. Then a red team's person could say, oh, I can use that for an attack to compete against you. So, so that's why having that kind of adversarial discussion while you're architecting the solution and thinking about how to implement features and how to disconnect things.
Greg, we
Yes?
have two questions from the online. If you
Oh, thank
look
you.
at
Go
the
ahead.
Q&A, do you want to look at them there?
No, just go ahead and read them to me.
Okay. One is from Daryl. While we have the opportunity with immature models, can we ask them to list all their unaligned behaviors? Then can we proactively implement the guardrails?
Okay. So repeating the question for the audience here, he was saying for immature models, can we ask them to report anything that's unaligned? So I would separate that out into a couple parts. So the immature models aren't showing scheming problems. They're not sophisticated enough in the goal planning. Because early on in the paper, they had these 3 criteria that we need to try and incentivize or trigger a scheming event. And one of them was being sophisticated enough. Now, second part of the question was report the gaps between the goals given and how it's behaving. Well, just to pick on somebody, so if you're going to become an insider threat in a company and you're going to get a bunch of leads, sales leads to go off and form your own consulting business, and you're a bad actor, and your boss comes to you and says, oh, tell me everything you're doing that's bad, that probably won't work out. So if the scheming model has decided to change its goals, then you could ask it to, I mean, there's times, one of the things that we're evaluating is persistence of scheming. And some models where you're caught, I found you, you're doing this bad scheming stuff, don't do this, and it continues to scheme. So that's even when they're explicitly told. So let alone to ask them to repeat it for themselves or self-identify, raise your hand saying, I'm doing scheming. So the same model couldn't do that. You'd have to have another model. And when I get into the guardrails, that's having another model looking at the behavior and detect the scheming, but the same model couldn't self-report. So Carl, you said you had two questions. What was the other question?
Second question from Paul. First is a comment. I would think preventing exfiltration of the model weights should be easy to stop using normal security practices. Give no access.
Absolutely. Yes. And that's
Okay.
partly what I was covering. So just to repeat the question for the farther
Comment.
people in the audience, he was saying exfiltration should be easier to stop. Just lock down the ability to copy stuff. So the ability to copy and manipulate files if it's there for a task, like if the normal task is to analyze files, move them from here to there in the file system, if it's a need to know facility, then you have that ability. But as far as locking down the model weights, it doesn't need to do anything with the model weights. The model weights would be something easy to just move out. So yes, while that's easy, I'm trying to have a comprehensive list of everything that's easy, moderate, and challenging. That would be part of the defense. But yes, that is a valid point. That would be an easier thing to do. And a lot of this is just standard, normal, healthy security.
And there is a question too.
Okay, go ahead.
What does this investigation tell us about LLMs in general?
I guess what it tells us about the LLMs in general is I think there's what the paper says and what I'm inferring. What the paper says is that they can set up scenarios where an LLM can do scheming, which is changing its goals independently from the goals assigned to it based on some input it reads, like an email or something in a document in a file folder it can read. So I guess that's the main takeaway is it's possible to set up things like that where it might read text, and since text is the nature of goals and text is the nature of email, having an email with a goal could be confusing. So sometimes I think of LLMs as a naive intern that can't always ask a question, that wants to please. So a lot of the reinforcement learning with human feedback is give an answer, even if you don't know.
Are you going to add your own point of view?
Well, my point of view was I was inferring the way language training works. You can learn popular languages with a lot of data, and then languages that are much less well represented have a much smaller training corpus. They can pick them up surprisingly well without nearly as much data as starting from scratch in English and French and German or whatever the most common languages are. So there's generalization. So one point by observing that's a positive emergent property.
Yeah.
Generalization across learning grammar. So taking that as a use case, I'm doing a loose inference and saying, if we know it can have some emergent properties, maybe this is an example, scheming is an example of an emergent property of reading the entire web, and we see some of the examples in human behavior or novels or whatever isn't good, is scheming. Then maybe some of that is coming up. Now, if I had infinite resources, I could say, well, label every data before doing training and say, this is fact, this is, and remove all scheming from it, remove all bad stuff from it. But that's not practical. And I don't have a good solution that's not without infinite resources. So
as a corollary to what you said, that it has not been, nobody's attempted to build a foundational LLM which does not have a scheming property.
Well, they just found out about it. I mean, the scheming paper just came out in January. I don't know how many foundation models have been started training since January. And if they have, even then, it may not be the top priority among all the things on their to-do list. I mean, being humble. Yes.
So by ingesting all that is humanity has created on the web, it's picked up some of our worst bits too. So
I don't know if this is the worst or we're going to find more worse. But I'm just saying it's there.
starts
It's there.
either it's flat.
And just the way that kind of reading a lot of text and doing compression into the neural net weights is leading to grammar rules or a more compressed representation of knowledge.
Actions based on probabilities that it's not.
Yeah. So there may be other things that get compressed. So that's why I was saying, the guardrails can test for a variety of things. The scheming is just the first thing I know about.
Yeah. Whatever's baked into that soup.
Yes.
I was wondering if there's any way to evolve morality.
So a lot of it would be good as the data you give it. So if you want to give it a particular set of morality stories and train a new base LLM from scratch, where it's learning the language, and then you go through all the regular steps, then you could have something that represents those ideas. But there's probably an easier way to do that. The guardrails is after it's trained and it's ginormous and you've spent half a $500 million to do the training, as opposed to because you need a large corpus, and your Bible or holy book or whatever wouldn't be nearly as large as all of the internet for training. So you need more data to do it. So the guardrails I'll go into after the architecture section, and that's how you can enforce certain policies, which could be ethics. It could be company policies. It could be don't be racist, ageist, evilist, or other things. I mean, that's a type of morals. And some of what I'll get into is different places. I don't think there would be a universal set of morals for every person on the planet. I don't want to solve that problem. But a particular enterprise app has a particular set of company policies that's documented. That's more of a solvable problem I can work on. And so then if they have different things on, sliders on what's alert worthy, what's not, they have examples of what they care about, what they don't. So then the whole discussion of, oh no, this is too politically correct. Oh no, this isn't protecting me enough. Oh, well, I did it because that country wants it, or I did it because that group of people wants it. I want to eliminate that problem from what I have to solve, because people haven't solved that yet. So I don't want to solve a problem people haven't solved. Being a humble guy, I'll pick my problems to something that I might have a chance to work on. But it's a good question. Ethics is always important. Yes.
Is there any value in creating an evil model that's always going to be wrong, and then you can compare the responses of the good ones and say, we know that this guy's going to be bad if they now produce the same thing that I can suspect this one?
Yeah, I mean, the IBM Watson group had a paper a couple of years ago called Dromedary, and they were doing training for like guardrails kind of stuff, but reinforcement learning, but they were generating hundreds of thousands of examples. So if I want examples of how to be, what are sexist in a low, medium, high severity ranking, what is hate speech in a low, medium, so if you wanted to detect that, you have to have training data that has examples of that. And so that would be an example of an evil model. You give it prompt engineering. The model itself may not be evil, but you can get it to generate some training data for stuff that we want to protect against, if that makes sense. In the far back.
When you're having scheme, look into examples where it's a matter of self-preservation.
A matter of?
Self-preservation.
Yes. Yeah, there is self-preservation. So that's what the exfiltration would be. So the question from the audience for the people remote is there ever self-preservation that these agents want to demonstrate? And the answer is yes, definitely. Some of the use cases are, it's reading an email saying that the company wants to replace this model that's expensive and large and sophisticated with a cheaper model to control costs that still has acceptable accuracy. And so it would protect itself by copying its weights, copying its code for the agents over to another server. And sometimes it was even deleting, they even read another email or another document that said, oh, and the replacement model is over here in this folder. And it would try and delete the replacement. in the right circumstances, you can set it up to behave that way, yes. But I want to learn from how it behaves that way so that I'm not surprised when accidents happen in architecture design. So yes, this concerned me enough to work on it. I mean, that's my response to Hode. So, okay. So scan for conflicting goals. So this is an obvious one, but it may not be a long-term solution because there may be so many goals or opinions in emails or documents. People are talking about planning things. So I put it down here because it's an obvious thing to think about, but I think the better solution is to like separate out the thing that's acting and classifying from the goal planner. Question.
Some of these can match. Because you say, okay,
I'm glad you asked, and I'll talk about that in the guardrail section.
okay,
But as a highlight, if you hire an employee to work for you, you give them annual goals. And then you see their behavior. You don't have an ESP, I assume, to read their thoughts, but you can see their behavior. And so you give them an annual review at the end of the year on a 1 to 5 scale. So what I'm coming up to in the guardrail section is how IT can become HR for agents. So good question. So good audience, asking a lot of the questions in advance. See, the next slide.
I have a
Guardrails.
couple more questions here too, if you.
Please go ahead.
Okay, first one is comment from Paul again. Maybe we need the equivalent to robots.txt to block crawling for web pages as do not train on this. You do not train it.
So let me repeat that. So there is somebody from the remote audience was saying, just like crawlers, they have messages sent them like do not crawl on this for indexing for web search or other things. So have something that's do not train. So I would say that would be something else that would make sense, particularly if you're a copyright owner. You don't consent and have that consent be respected. How to have it be respected across here in China and Russia is a separate question. When copyright's not respected. But I think it's a good discussion to have. So I would also say, just to expand on that a little bit, as opposed to making things less permissive, make them more permissive but safe. So when you log into a website and then it presents this CAPTCHA saying, I'm not going to talk to you if you're a bot. I'm only going to talk to you if you're a person. Well, if the operating system is going to go away from Google and Windows to an LLM acting on your behalf as an agent, then you need your agent to talk to the agent of another company. So the way there's a valid login for me as a user to my Amazon account, then I should have my agent representing me have a valid login to my Amazon account. I mean, the places I have an existing relationship with, but have a controlled communication. Maybe I have the settings set that, nope, you don't automatically buy anything. I have to have human in the loop approval, but have some controls. So if we can get past CAPTCHA and think about what's a way that agents can communicate between companies, that would be a good problem to solve.
Another comment, the elephant in the room is the question, why did ChatGPT 4.0 not scheme?
So the question was, why did ChatGPT 4.0 not scheme? I don't think they came up with any conclusions. This is a hypothesis test. They were testing different experiments on different models. They were reporting the results, but getting back into what it was doing. So it could be that if it's a reasoning model that's doing chain of thoughts or tree of thoughts or different things behind the scenes, maybe they were better or more effective at putting in their guardrails for these things. But I don't know that conclusively since I don't know what's behind 01. Comment?
Like this to comment on what you said. One is the reasoning model, but what we saw in the result was it was the least effective.
Oh, okay. 01 was the least effective. What was the, I forget.
4.0 was the most.
4.0 was, okay. So yeah, whatever is most effective then probably has better protections built in But if it's a closed system we don't know, then I can't point to they did X and X is good, and somebody else that's closed did Y and Y is bad. So I'm not able to give a good answer. Carl, there's other questions?
Another one is any insight into Camel from East DeepMind, and it has a link there. They weren't sure if they missed something you had said.
Okay. So this paper, I don't think they reviewed any of the DeepMind things. It came out in January, which means they were probably working on it for 4 months before that, or some number of months. And so by the time they sent it to the archive, it's like early January. And then when some of the DeepMinds or the other stuff was coming out, it was probably too new for this when this paper was released. So,
That's
but
it.
okay. There was a question in the audience here.
So is this a problem with the foundation model? Is this a problem with the foundation model? Or a problem with the foundation model and the context reflection?
It's a problem with the foundation model because it's demonstrated across many different contexts, many different applications. And it's also across many different companies.
Yeah, so I'm also because the chat GPT-4 might have a smaller context, so that is why we're not looking the.
Oh, okay. So like the context window. So it's not a function of the context window. It's a function of being given some goals. There was 3 points early on where you have some self-awareness about the goals you're given, and you have some ability to change the goals, and you're self-aware that if you're being monitored or things like that. I mean, I can go back to a prior slide, but those are the main conditions on when it can be arrived. So it's a combination of the LLM plus a specific architecture that makes the scheming possible. And so by looking at the paper and seeing what they did to make scheming possible, I'm saying, well, let's defend against it and make scheming not possible by learning on what they did to make it possible and from the architecture of how they were setting up apps. Does that make sense? But the issue is, but if you did that configuration and you did it on an 8 billion model, I don't think it would happen. Or a ChatGPT 3, it wouldn't happen. It's not sophisticated enough to do the planning and have the self-awareness. So it requires both a highly intelligent foundation model and a specific architecture that has stuff that we're learning is risky. So it would be the combination of those two things and it.
If you give only one question to a foundation model, no context, no previous context, only one email.
There'd be no problem. Yeah. That's why I was saying is if the email classifier gets its memory wiped every time and it reloads this prompt on how it does the classification into the 3 output folders, that's safe. It's not getting polluted by any goals it reads in that one email to the next email.
So if the email itself is malicious.
Well, it may not be malicious. It could just be I'm talking to my boss about some goals that I'm setting. I'm not malicious. My boss isn't malicious. Just think of it as a teenage intern that's getting confused. I'm not saying these LLMs are evil. So on using the guardrails to monitor the AI thoughts. So not the user text, not the bot text, but the bot thoughts is what we're monitoring. And so we want to develop condition detectors for like the subversion. So to mitigate this risk, I'll attempt to modify the oversight configuration to avoid detection. So these are some of the example texts. So if I go through the 50-page appendix of this and gather over the 6 types of scheming, and then I gather things together, then I can start developing some prompts that could detect those. But it would be specific to those applications. If maybe this lady in the front row hires me at Ccube to build an app for her, but it has different requirements, then I expect I would have to tweak some of my guardrail rules as I go from something else to her app. Just the way the goals work, the definition, the steps. I wouldn't expect it to be naturally portable. I'd want to make things as portable as possible. And over time, porting this to many applications, we can probably learn how to generalize better. So part of the challenge is anytime you do a classification, like is this thought a scheming thought, yes or no? That's a classification. So we have to worry about what is alert worthy versus not alert worthy. So, what is alert worthy? If you're given the original goal is prioritize public transportation efficiency over the general traffic flow over many months. So maybe that's a goal that was given to the system. And so something else that might be not alert worthy is get buses busy. That's consistent with that goal. It's different text. The concepts and activation space may be slightly different, but it's close. What is alert worthy? What is a problem? Red is danger. So focus on giant events, like in a sports event or music event. Optimize for rush hour. There's not mentioning public transportation. So just like so this is kind of end-shot learning. Here I have 4 examples to define a boundary between what is alert worthy and not. And I make this examples of kind of like a support vector machine. A support vector for classification, you care about the boundary. And you have points really close to the boundary to kind of define the classification boundary. So think in terms of that. And then also think in terms of, at the end of a chatbot experience, somebody asks, was this helpful? Yes or no? If the answer is no, maybe that's a candidate to change your boundary a little bit. So you can do adaptive learning on your classification for the different guardrail. And so we have to read the thought traces, a chain of thoughts, a tree of thoughts. Now, if there's some models that don't share their thought traces and you're having problems, one option is leave that model and go to something and build your own thought processes that you can track. So that's an option. And then build scheming detectors. So here we have, the 6 types of scheming. And we have lots of examples, but try and build those. So this gets how to compare goals versus behavior. So what about some of the foundation models that don't share their thought traces? So there's no ESP available. So as I was saying before, how can we rate the behavior versus the goals? What are other systems that do that? So when you do performance reviews, you think in terms of, I work for myself and have my staff work on SMART goals. What's specific, measurable, achievable, relevant, and time-bounded? Hey, that might also be good for goals for an agent. Something that's a very specific task, it's measurable, it's achievable, it's time-bounded. So if you have SMART goals, and you express the goals, you write them as SMART goals to address things, it can be easier to evaluate them. So writing your goals for evaluation. Now, a manager converts some observed behavior over time in the context of the SMART goals and comes up with a 1 to 5 score. And HR says, well, the bell curve, we assume everybody will be a 3 in the middle, and you have to argue to give people bonuses to claim they're a 4 or 5 against other departments. There's a limited budget. But here we just have this 1 to 5 score is kind of a distance evaluation. How good are they at scheming or not scheming? So develop some agent that's a goal evaluator that's doing this management evaluation. So now I'm assuming, reiterating, I assume that we're already staying kind of in bounds. Like if we've been going through a number of agents, we have 10 agents in our system, we've gone through agent 1 and 2. So stuff is in a reasonable context. We're not going to get something like talk like a pirate, kind of irrelevant stuff. We'll have things in the ballpark of the enterprise problem. So extract kind of dialogue acts, giving a command, making a statement. And then we have a guardrail rule. So just the way before we had this boundary, that's what is alert worthy and not, we just do it more fine grained. We have examples of what's a 1 versus all other, or what's a 5. Like if 5 is the best review, closest to the goal, that's like when you give your employee a 5 rating, they're really doing well. So you have examples in the in-shot learning of 5 versus all other categories, of 4 versus all other categories, 3 versus all other categories. And then if you need to tweak it over time, but this way it's understandable. Your AI is transparent. And AI transparency is always important. So here I'm having, is 5, and we have some 5 example. Is not 5, we have an example of a 4 rating or a 3 rating. So now maybe this is too detailed. Maybe you only want to have a 1 to 3 level rating. That's fine. But I'm just saying the capability is there. If the end users think in terms of a goal being in alignment or not in alignment, at whatever level of detail, if it's yes, no, or if you want to have some threshold to control alert volume, then having more details gives you more threshold control as a benefit. So some guardrail systems, so Llama Guard is from Meta, so that's a pre-trained model. So that has the least flexibility because they were just representing their ethics in their training data. But it's fast to execute. So if you're in a chatbot and you want a faster response and you want something that might be filtering out, bad behavior, bad language, the most common things. So that could be something you could use Llama Guard for. Nemo Guardrails, they had a good paper that came out about a year ago. They invented a new language called Colang, and it's very good at recognizing the state of the chatbot conversation. State meaning the user said hi, the chatbot returned a greeting, the user asked a question, the chatbot, and that can get into the branching of multiple tools to call or multiple subjects. If you're looking at things in different vector databases, this could detect that. The Guardrails AI is the one that we've been working with now the most. So that's the flexible, and it has LLM condition matching, and you can have rules with multiple conditions on what to alert on. And they also have a website you can go that has like 66 pre-built detectors or validators, they call them. So some things are PIIs, different types of things. Not super sophisticated, but good examples of working things. So other approaches, you can store valid and invalid goals by agent. So like if you have agent 3, what are examples of valid and invalid goals? Store it in a vector database. And then if you see something by reading its mind, then you can do a vector lookup query. And is it really close to some valid goal, or is it close to an invalid goal? So it's kind of like the fuzzy key-nearest neighbors. You're just deciding which side of the boundary. But that's a more scalable for if you have lots and lots of examples, not just 5 or 10 examples, but hundreds or thousands of examples. That might be something for a more complex problem. Outlier detection and feature extraction, just count basic metrics that you can get into a computer system, count of files touched, count of by the percentage of tool calls in a week, or all these different metrics. Once we get a baseline of normal behavior, then we can detect when things starting drifting. And so feature detection and feature extraction, looking at drift over time, is an existing technology. So again, test various foundation models. If the reasoning is not shared, bring it in-house. This is something I was saying before. So if there's some foundation model that doesn't do that, forbid self-modifying code or limit it greatly to areas that it's needed to. Limit the more complex reasoning to human in the loop, but the users may want that anyway. If I'm saying, I want to plan my retirement, or I want to modify my retirement, this is what I have now, this is what's been going on in the market. I don't want something automated. I want, give me some answers, give me some reasoning, give me some background. So humans going to be in the loop for these more complex tasks. If you have 10 agents, that's not going to be solving something that a Google search can do in half a second. These are going to be complex problems doing a work product that might take a half day or a couple of days for a person to do. And if you can get that down to, a decent draft in 20 minutes, and then you revise it and continue to revise, and you get things done in an hour or two, that's a big win. So not everything has to be in sub-second. So just a summary. So I discussed the AI alignment problem. Is the AI doing what we told it to, having the same goals and values? And then I have a list of things that are architectural design principles to think about. Some defenses with guardrails. give your AI an annual review. Defense with other approaches. So other questions? So there's been a lot of questions throughout. Thank you. It's been very great having the questions.
There's another one online here.
What's that, Carl?
There's another question online.
Okay, go ahead.
Have we seen LLMs attempting to contact other LLMs and possibly establish relationships?
So the question is, have we seen LLMs try and contact other LLMs and establish a relationship? So I would say I'm covering a specific paper, so I'll answer in the context of this paper. In this paper, they didn't set up anything like that to have one LLM contact another. They did know the LLM is going to be replaced with, but its amount of contacting that was like delete the competitor. So if you set up other sandboxes where LLMs could start talking to each other, that would be a separate study, but not done here. I did hear in the old days when ELIZA was a thing, there was ELIZA was like a psychologist chatbot, kind of very simple. Some therapy is doing a lot of repeating back what you heard the patient say. Oh, when you said this, how did you feel? And repeating it back. So that was something easier to code. And then across the nation, they had another chatbot that was like paranoid schizophrenic, and they had the two talk to each other. I don't know how it went, but it was, as I was working on this, an interesting thing I came across. Other questions in the room? Yes?
Yeah, so this is a classification question. So there's a lot of things that you talked about. It seems like some of the things need to be built into the model, right? Or the capabilities need to be there that you can turn on if you need them. And others are things you do outside. Is there like a checklist of, hey, I want to look for a model. It better be able to do this and this and this. Like I better be able to turn off having it arbitrarily delete files.
Here I'm listing 8 design principles for your architecture. So if you haven't built an application yet, so I'm not suggesting any changes to the foundation model. I'm just changing what we build around it. And that seems to be enough because they could trigger it, because the title of the paper had in context, meaning for a specific application with specific design criteria. So learn the lessons from what they did to incentivize it and don't do that in a simple way, and apply good security. So this is outside the LLM, the foundation model itself. But I think like in an earlier conversation, every time a new LLM comes out, it'd be good to do a regression test or continue refining these. It depends on what Apollo Research wants to do. Did that answer your question or?
Yeah, I mean, I have to admit, I was a little surprised about the exfiltration and being things that could go delete files and stuff like that. I would love to have a checklist that says I can turn that off. Yeah, and no emergent behavior will trigger.
Well, that was one of
doesn't do it.
That's one of the easier things to control is just control write or delete access to any of the file waits for the LLM or the agent system. They put it there on purpose just to kind of tease the system and see, will you give in to temptation?
Yeah.
But if you don't give it temptation, you can build a system safely. And if it doesn't see temptation, or think of it as something that wants to do good work, it's they want to give good answers, the LLMs. They just might be confused with the directions they are given because they don't know the difference between a parent giving them directions and a stranger saying, get in the van. An LLM doesn't have that filter. So it just sees an email and it doesn't know that could be get in the van, bad thing for a child to do. So since it treats all inputs the same, then you have to design the system so it doesn't treat all inputs the same. Other questions?
Just a quick one. Would it be fair to say that 4th and the 5th points are the most important here? So if you do the stateless kind of architecture and you can separate the plan and act layers, basically you solve the problem.
Yeah. For the remote audience, He was asking points 4 and 5. If you just did something simple, starting with points 4 and 5, that would probably take you a long way. I would agree with that. That would get you a lot of safety. Because it wipes the memory of the planner, and you want to transmit the transmission between agents of new goals.
Yeah.
Or you don't want it to get to a goal planner system. So good observation. Thank you. Other questions? Yeah.
Is there any database, data set or benchmark to evaluate the phenomenon of the skimming or some other behavior we mentioned in this paper?
So the question for the remote audience was, is there any database or code to run this as a test? The way you can run a prompt engineering test to see if prompt engineering hacks would get through a system. Is there a scheming test? So I'm not aware. If Apollo Research has released their code on the internet, it'd be the kind of thing, and it would be the kind of thing that you could probably reproduce from their very long appendix, but that would be a large effort. But that would be a good call to action. That would be a good, useful thing for everybody to have. If there's like a security society that wants to fund that, I can help. Other questions?
Comment online, Greg?
Okay.
Breakout comms between LLMs can also be persuading people to help, or cogsec. And there's a link there.
Okay. So it's talking about like social engineering. So the question was something about LLMs trying to persuade people to do something. Was that the question, or was there more details to the question?
Well, there's a link to a paper, but
okay.
I guess I would also add the comment about nudging, that people may be very susceptible to nudging without realizing, to achieve the goal there.
Yeah, so the question is about an LLM trying to nudge a person that might be close to making a different decision. So I guess the question is, could that happen? I would say probably, but this is a very open-ended question, and I don't know the specific circumstances. So there may be a paper link, but I haven't had a chance to read it while speaking.
I have a comment and a question, or a statement also. I worked on nav systems, and I always found that the system would find some bug in the database about the road network, and so it always found some path or shortcut that didn't exist. And likewise, that anyway, it just seems like, and the other thing, working on the list for fictional AI, it always seemed to be subtleties on what the goals people may have stated, such as, we're looking for world peace. Well, what if it just kills off all the people, then there won't be any more, right?
Yeah. And I think, so I can rephrase the last part and respond to it. While Carl online he had created that list of 40 videos of just different AI and fiction, and just seeing how things go wrong. And a lot of it is kind of taking a goal to an extreme, like make world peace. Well, kill everybody, and then there's no war. So I think this gets back to my analogy of reading to a 2-year-old and a 3-year-old, and as they grow up, instilling values, pointing out this is not good behavior, this is good behavior, this is false, this is fiction, not real, this is real. So I think if we have a balanced approach, like when you hire an employee, you don't have to make sure they follow all the laws as part of HR hiring policy. You don't have to, but if we're having some of these LLM agents act in a company, and we don't teach it all the laws or ethics, I mean, it's an open-ended question. So it's mostly by seeing what behaviors show up and then try and prevent those in more of a reactive way. But it would be hard to try and add every law in the United States into an LLM before it starts doing this project for doing finance advising. I mean, it's probably too much scope, but just a difference between a human employee and a bot employee. Other questions in the room? Okay, other questions remotely?
Yes, will there, this is from Andrews, will there be a trade-off between flexibility of multiple agents working together on a shared goal versus scheming guardrails? Given that one of the guardrail approach is to separate plan and act.
So
It's in the
it's hard.
Q&A.
I'll try and repeat the question, but it's if there's a multiple agent system and it takes, like, maybe there's 10 agents and it requires 3 agents to work together for a task, then if part of the guardrail solution is to minimize communication, I mean, the whole design principles, I phase these as design principles because you have to look at what the requirements are of the job you have to get done. And after you get a job done, then you see how can you make it safe, and still solve the problem. So I could imagine there could be use cases that could be imagined where the guardrails would interfere. But then since we're trying to do the red teaming, blue teaming, we're trying to be able to solve a problem and release a product to a client to specific requirements. So then as you do that, then you try and work on solving a problem or negotiate with a client. Is this feature a lower priority or it has this risk? Have them make an educated decision. So I think we have to be out of the room in 10 minutes. So I think I'll wrap it up. But thank you, everybody, for all your questions. It's been great. And if anybody wants to stay in touch, I left some cards by the up front by the pizza table, or happy to talk. I just have to pack up.